All right. Hi, everybody. Thank you for joining us today. I'm your host. My name is Dipankar Dutta. I'm a research analyst at Block, and I'm very excited to host today's webinar, where we'll be exploring the Layer-1 smart contract platform landscape. I'm sure most of our audience at this point is very well versed in Layer-1 blockchains. In short, they make up the fundamental infrastructure enabling all of the blockchain-based applications that we all know and love. And that starts from decentralized finance or DeFi, transfer of stable coins, NFTs, and many others. So today we'll be getting into a discussion surrounding some of the novel technologies that are in the space. And some of the discussions will revolve around blockchain architectures, generalized chains versus application-specific blockchains. We'll also look at layer 0 chains, which may act as a hub for a whole ecosystem of other natively interoperable L1 blockchains. And lastly, we'll also touch on the communities of people that are being built up around these ecosystems. Our audience can find our report titled Comparing Layer 1 Platforms 2022 edition on the Block Research website. It's live now, and it has much more details and nuance regarding some of the topics that we'll be discussing today. But I can't wait to dig deeper into all of this with our stellar panel of 5 experts. Today we have Austin Federa, Head of Strategy and Communications at Solana Foundation. We're also joined by John Woods, who's the Chief Technology Officer at Algorand Foundation. Luigi DeMeo, who's the Head of DeFi at Ava Labs. Sebastian Bode, who's the Director of Engineering at Cardano Foundation. And Stefan Sopic, who's the Head of Engineering at Parity Technologies. So let's go ahead with the quick and brief introductions of our panelists along with their backgrounds. We'll go in alphabetical order. So let's start with Austin, then we'll go to John, Luigi, Sebastian, and last but not least, Stefan.
Great, thanks for having me on today. I'm Austin Federa. I run strategy for the Solana Foundation. I've been with the organization about 2 years at this point, so started in January of 21. And so my role here and the role of the foundation is obviously to help support the adoption and advancement of decentralized technologies and the Solana blockchain. So excited to be here today and talking about L1s. It's where all the exciting things are happening.
Lovely. I'm John Woods. I live in Dublin in Ireland, and I'm currently the CTO at the Algorand Foundation. And I've been here for just coming up on a year. Prior to this, my background was also kind of involved in crypto. I was the chief architect at Cardano, or at IOHK, building Cardano, and I also led applied cryptography there. And then prior to that, the only other kind of crypto relevant thing I've done is I led architecture and applied cryptography at Consensus, which is an Ethereum-based studio. So I've worked across 3 major and significant chains now. And yeah, I'm interested in layer 1s and excited for the discussion today.
Hi, everybody. Luigi DeMeo with Ava Labs. I've been working with Ava Labs to help bootstrap and sort of shepherd the Avalanche ecosystem. Been involved for Avalanche almost 2 years at this point. Background was really in traditional finance. Worked at Citigroup for about 7 years, holding multiple different hats on the trading side, but kind of got involved in crypto back in 2012 with Bitcoin, and then Ethereum back in 2015 when it started to get launched. So had my own dApp that didn't work back in 2017, and ever since DeFi came around, was super excited about that. So help shepherd the DevRel and DeFi ecosystems for Avalanche, and excited to be here.
Cool. So hello, everybody. I'm Sebastian, Director of Engineering at Cardano Foundation, which basically means I oversee most of the development activities at the foundation, as well as the Department of Technical Integration. So the guys that help third parties to run the Cardano components, basically. And before joining Cardano Foundation with the beginning of last year, I did a typical German career, I would say, working in aeronautics, automotive, finance, and also computer gaming, which eventually led me to the crypto space. Yeah, so super excited to be on this panel.
Hi, everybody. I'm Stefan Sopic. I'm Director of Engineering at Parity Technologies, which is a lead developer behind Polkadot. I've been in Parity for 2 years now, and before that, I think I entered the crypto space around early 2018, and started my own DApp. Figured out that I think I need my own blockchain, and then literally Googled blockchain building framework, found Substrate, and the rest is history. I'm very excited to be here and talk to you guys.
Well, I'm very excited as well to have all of you. So thank you for taking the time. A note to our audience members, please feel free to type in any questions you may have in the chat box. There will be a 10-minute Q&A session at the end of the webinar. Let's tee off our conversation with the past 3 to 4 years, which, as we all know, has been very eventful, to say the least. We've seen huge advancements in novel technologies that are coming out. We've seen huge growth in user adoption of digital assets, but we've also had major failures, both from the side of smart contract hacks and exploits, but even meltdown of multiple centralized and major institutions in the space. So as some of the leading smart contract platforms in the space, has these developments in the past few years affected the pace of innovation on your platforms, and has the mission changed at all? Let's start with Austin.
Yeah, the last 3 or 4 years have been pretty monumental for the industry as a whole. I think what we've really seen over this period of time is that what started off as 1 or 2 visions of what this technology could be, Bitcoin and Ethereum, has expanded into a lot of different types of applications serving different types of use cases. We're all talking here today about, smart contract platforms, but there's storage networks that use block weaves, which are built off of some of the same underlying technology. It's very interesting to see all these different applications of what really started off as a pretty basic core technology in this space. If you look at a network like Solana, mainnet launched in March of 2020. So we're just coming up on the 3-year mark of this. And, from a technology standpoint, it was really against the trend at the time that it launched, right? Continuing to use one single global state as the scaling solution, as opposed to looking at charting or subnets or something along those lines. And so that is a different type of architecture than you see in a lot of other chains. What's really interesting to see is that all these architectures are, coexisting. There aren't necessarily 1 or 2 that are winning out over others in the space. And especially with the fundamental characteristics of Ethereum, almost unrecognizable from what it originally launched in to what the vision of that will be in a few years. We've seen the industry be willing to do a wholesale reinvention of what a platform means in the space. I think that's really fascinating to see, and it means that there's still a ton of room for innovation and still, a global crypto community that's open to changing things up and looking at things in a different way.
I would maybe go next and add to that I agree. I think, at Algorand, and even when I was at Cardano, we're not interested in killing Ethereum or killing any of the other chains. I think very much like software and computer engineering, which gets me excited because I'm a nerd. There's many different languages, and therefore use the right tool for the right job. And I think some blockchains fit certain use cases a little bit better than others, and vice versa. But I think having a vibrant distributed systems engineering movement and a vibrant innovation in applied cryptography is so important, and we're at a very wonderful time. And just the last thing I would say, yes, the last couple of years have sucked, especially in recent times when there's been some, I would argue, centralized failures of regular businesses that have actually caused a big downturn and sometimes consumer distrust. And so, you asked a question, do I think that this has impacted the innovation? I would say, looking across the spectrum of all the chains on the call here, no, I don't think it's impacted the technical innovation. Has it impacted the consumer trust? I think maybe, and that'll take a little bit of time to win back, unfortunately.
Yeah, just expanding upon that, I guess, we sort of had this movement where we kind of forgot a lot of our core values in the space. A lot of the reasons that most of us, I would assume, came into this space was for non-custodial use of assets, being able to hold your own assets without having to rely on others, being able to transact those, all those types of use cases were I think why we came in. And then what ended up happening, I think post COVID and post sort of like, risk assets get quite a bit up is maybe some of those core techs were still maturing, and to fill that gap, you saw some more centralized services come to the fray, and users flock to those like the Celsiuses, the BlockFis, Voyagers, et cetera, FTX. So, I think generally speaking, this is a good thing, net that these all, kind of haven't continued to progress, and now we can get back to the core values. And I do think that the core innovation has actually accelerated in a big way, not only because of this, but because, some time was bought in between those, that bull market and kind of where we are now. So I do think we are seeing, a nice acceleration.
So maybe to add on this, from my perspective, it's also very nice to observe that during the last years, the whole evaluation of this whole progressing of the blockchain space felt pretty natural. So we started with proof of work, then had proof of stake, had smart contract platforms. We added roll-ups for scalability, optimistic, zero knowledge, and now ended up in a space where you can build your own blockchain with frameworks like Substrate, for example. So application specific blockchains, but you can link those blockchains via bridges or other approaches to those maybe bigger, more decentralized blockchains, and achieve that super good level of security and trust in it. And so this is all the technology side, which progressed very well, I would say. And being a technician and engineer, this is super important for me. But what also is now interesting is to introduce this governance side of things, and venture into a space where we have open governance, transparency, especially when it comes to the decision making, how to evolve further the technology, but also on how to apply the technology to the different use cases.
Yeah, I would say I agree with everything that is said, and I would just, when we said that we were going to talk about this, I was really thinking about the last couple of years, and what stuck to me was this 6 years ago, this dream of the multi-chain future that we all had, and which is actually now a reality, and it's here to stay. And you can see that across all the L1 ecosystems. And some of the ideas that were laid out in the Polkadot white paper have been like architectural inspirations of many projects, and it's just so cool to see the whole space moving in that direction. And I would say that when it comes to some of the downside that happened in the last year, I would definitely agree with Luigi that it just put the value of decentralization back into the focus, which I think net as well is a very, very good thing for the whole space. And yeah, we kind of got blindsided a little bit by a lot of the improvements on like user experience they came at a cost of decentralization, and now we are returning the focus where it should be. And I think that is in general very good for the space.
Yeah, and I kind of do agree with all of you that, and maybe a lot of things that happened in the past few years was maybe a force for correction towards what the space actually stands for. So let's kind of transition to discussing a little bit more on the key focus areas of this discussion, and that's scalability, right? So blockchain scalability has been one of the oldest bottlenecks, has been one of the most persistent pain points in the space. And all of you kind of touched on it a little bit already, but there's plenty of proposed solutions for scalability of this whole idea of block space scarcity. But before we get into that, I kind of want to touch on the definitions of things. So how would you go ahead? How would you define what is a scalable blockchain? Like, can we measure it through transactions per second? Can we do it through time to finality? Is it settlement assurances? Is it all of the above? Let's start with Austin again.
Yeah, I mean, any definition is always insufficient to encapsulate the whole realm of what something could be considered. I want to start out with that. I mean, people have been trying to decide what decentralization means since blockchains were invented, right? When we're talking about scalability, though, time to finality is really important for some applications. For other types of applications, maybe it doesn't matter as much at all, right? I think when we're looking at what scalability means, the Solana thesis here is that you build the fastest, highest throughput, lowest latency layer one you can, and then you look at extensions off of that where those are necessary. So there are certain types of clients and use cases that really prefer to be on something similar to a sidechain or a subnet, or call it a rollup, right? We're all talking about similar implementations of different core technologies there. But the Solana bet is that you make that base layer one as fast as humanly possible, and that's where you deliver scalability from. And that scalability can come from software innovations and it can come from hardware innovations. I think one of the great things about the switch to proof of stake across the industry is now there's the ability, and this is another core thesis Solana is built on, that Moore's law or something very approximating Moore's law will continue into the future. And so you can predict that about every 2 years, the computer you can buy for X amount of dollars is going to be about twice as fast. And so you can make a lot of assumptions about validators and their performance scaling into the future just based on hardware performance. Software is obviously an important component to that, but software scaling is usually less predictable than hardware scaling. Software scaling can go nowhere for 2 years and then do a 20x jump, whereas hardware scaling is usually fairly linear progression over time. So I think those are kind of important things to consider when you're talking about scalability. But focusing on one metric like just TPS or just finality or something along those lines, I don't think really gives a cohesive enough picture of what we talk about when we talk about scalability. I think part of scalability is also flexibility of how you're able to use a given L1. It's not just what the stats of that L1 are.
I completely agree. I think that I don't like quoting TPS, and even though Algorand has a high enough TPS that I can kind of flex on it, I don't bother doing it. I think that Austin is right. What I would say is all of these things in engineering, when you're building these systems, really, what we're doing is the bleeding edge of engineering, because it's the intersection of cryptography research, applied cryptography, which is taking that research and building real world systems with it. Distributed systems engineering, which is where you're kind of building systems that are connected but are not locally all together, which is it's a unique discipline on its own. It's of course software engineering and software architecture that in a sense as well, and it's performance engineering and QA. And so really it's the hardest type of computer engineering I think that I've worked in. And I would say that scalability is a spectrum. It's not like, I think, you can't ramp up all the knobs at the same time because something's going to give, in my experience. And so, I've seen blockchains that have very high TPS, but maybe that number dips in certain scenarios when you're executing certain types of contracts or whatever. And so my general feel is that growing with your users is the most important. And so does your blockchain give a good user experience? And what are the requirements that you're trying to satisfy in terms of your scaling properties? And so, most blockchains, you can kind of slice them into the consensus layer, the network layer, and the ledger layer, kind of the rules of the blockchain. More or less, you can kind of slice them into these kind of components. And so, how fast is your consensus? Does that need to scale out faster than your network layer? We're limited by the speed of light, in terms of data propagation. So I think ultimately, once you're building a network that satisfies the demand of your users and is giving a good user experience to the applications while satisfying the virtues of why we're doing this stuff, which is like the self-sovereignty, the decentralization, the permissionless nature, I think you're onto a winner.
Yeah, I think I agree with some of the points previously. In terms of defining throughput, scalability, etc. Avalanche takes a much less opinionated approach, I think, in terms of its architecture. We scale horizontally via subnets. So, you may have certain subnets that have a very specific use case. And because of that specific use case may require more load. And if they require more load, they may require a different virtual machine or something of that nature. All of this is sort of umbrellaed under the innovation that I think the Avalanche team brought to market, which was the Avalanche consensus. This does allow for subsector finalities with validator accounts that grow. This is an important component that you want in your blockchain, right? You want to remain decentralized as a whole while still being able to, number one, achieve finality, number two, achieve high throughputs. What we've seen sort of in a lot of, in terms of these TPS like metrics and a lot of these debates is I think a core lack of focus on some of the important issues. Number one is the virtual machine. If you are using the EVM, this is a virtual machine that tries to do basically everything. And because it tries to do basically everything, the throughput that it can achieve in the long term is actually capped. And so if you're just trying to talk about TPS of the EVM versus something like Solana VM or Move VM, that's not going to be like a proper comparison. And so what Avalanche provides is the ability for you to have your own subnet with your own custom virtual machine or a virtual machine that already exists. And thus it's less opinionated from that standpoint. So throughput is sort of defined from that perspective.
I mean, what I really like in that space is the vast flexibility that we have given the decentralized architecture and different approaches on how to leverage the blockchain itself. So I would actually say it can be difficult, but it's also a lot of fun. And when it comes to rating the performance, it's definitely not about TPS or how many smart contracts or how many operations can get executed by the infrastructure itself. It's more, so it's very bounded to the context you're actually in or the domain you're building the application for. And because this really defines what performance is in terms of value exchanged, operations performed, maybe supply chain events recorded or something like that. And as long as the layer one platform allows me to be flexible in terms of how I implement those domain-specific applications, I'd say I'm fine with it. But of course, architecture is also always about, especially when it comes to performance, about trade-offs. So, for example, I can sacrifice security for performance. So make something less secure, probably have less validators, but trade it for performance. But I somehow have to in the end come to like a foundation and see where probably I can make no longer any trade-offs. And that's also a reason why Cardano worked, especially during the last year and still going on this year on a couple of scaling solutions to overcome those kind of things.
Yeah, I would like to, I agree with a lot of the points that were made, and I would just like to go back to the kind of the origin of the question, which was like block space scarcity. And I would say the decentralized applications and protocols can operate generally at the lower cost to their users by acquiring block space basically on demand instead of running a chain 24/7. And this is a concept that we at Parity and with the Web3 Foundation researchers have been toying on since 2019, basically kind of creating this parallel between cloud computing, which actually won over dedicated server space because it allocated physical resources in a more granular and adaptive manner. And similarly, block space centric architectures for Web3 based layers can actually outcompete the blockchain centric architectures. And when it comes to that, we've been working with this concept of parathreads, which is basically blockchains on demand that basically get finality and settlement when they need to, when they fill out the blocks. And in that regard, it actually provides a bigger, I would say, playground for the developers to play around with different apps and concepts, and when attaching to the chain are actually entering Web3 space.
Yeah, so it sounds like a lot of the scalability is very context specific, kind of depending on what kind of applications are trying to be implemented. Excuse me. So yeah, I think all of you kind of touched on the different approaches for getting towards scalability. We kind of talked about, layer 2s, layer 2 scalability solutions, potential of sharding that might happen in Ethereum at some point in the future. We also have offloading transactions to other blockchains, and this ecosystem of multiple interoperable chains that Avalanche, Polkadot, Cosmos are pursuing. So one of the things I also want to talk about a little bit is, what are some of the potential compromises that are maybe at play for some of these scaling solutions when it comes to interoperability, when it comes to composability, and also security. Can you discuss some of that? How are the platforms that you are associated with? How are they structured in this regard? Again, let's start with Austin.
Yeah, composability is why Solana is built in one global state that doesn't rely on sharding or subnets, because that sort of atomic composability that you saw really pioneered in the Ethereum landscape, where you can take a flash loan, it can go through 12 stages, and it can get repaid in the same transaction. Those sorts of things were really key innovations that changed the nature of what was possible to build in distributed systems. And so when you look at that place with composability, like formal verification and type-rich bytecode are coming to Solana, which are going to reduce the amount of plumbing you need to do calls between different programs within that one global state. But certain types of applications really depend on composability. DeFi is a huge example of that. There may be other applications like gaming where composability has a little bit less of an application there than it does in other types of environments, just depending on how these things work. And, when we're looking at that, the interoperability piece is still very unsolved. I really like the direction that messaging bridges are moving as opposed to asset bridges. That feels like probably a safer move, in my opinion, where you may have, let's just take a nice safe asset we all love like USDC. You may have USDC existing on multiple chains, and the bridge is not actually sending a wrapped version of the asset over. One contract is talking to another contract. There's a really cool version of this built on Avalanche with, unfortunately, Terra, so it was only live for about 2 weeks, but you could call the anchor contract from Avalanche using Wormhole's messaging bridge. And so you actually just had a front-end contract on the Avalanche side. You didn't have to have a full copy of the anchor contract on the Avalanche side to make that work. That was a really cool pilot of the type of thing I think you can see in cross-chain composability. There's other applications of this that we're already seeing on Solana, where, one of the earliest applications to migrate to Solana was Audius. Audius is a decentralized Spotify competitor. Their main token for a long time was an ERC20 token. The music that artists would upload was actually stored on IPFS and sort of the Ethereum world. But on Solana, that was where they were paying out all of their rewards. They were tracking all the user activities, the play counts, to give artists full transparency and view into that. And that was something that just financially was not viable to do on the Ethereum network, but they could use Solana as the execution layer for certain components of the application that they felt they couldn't build natively on Ethereum. So I think we're going to see, I really hope we see more of those types of applications where different advantages that fit different types of use cases of different chains start to become more common. And the idea that, like, I am only an Ethereum developer, I am only an Algorand developer, right, whatever it happens to be, starts to move away. And instead, it's much more like you see most modern companies are not 100% AWS, 100% Azure, or 100% Google Cloud. They're using different types of applications and different types of settings to match whatever they need to do.
Yeah, interesting. I think as well, I really like the message pass stuff as well. Algorand rolled out, I don't want to turn this into an Algorand hype call, but we rolled out something half cool, or pretty cool rather, I should say, called state proofs, which are, this ability to build trustless bridges, right, using math rather than validating like people validating. And so we've seen an implementation recently that used state proofs to do basically a bridge that was able to, not issue wrapped assets. And so I love this as well, because it feels so much more like correct to me. Like this idea of bridging wrapped assets all the time is just a pain in the butt, because then you have to have like your wrapped coin listed on the exchange back to the original version of the coin. And so it's a bit of a pain doing that. It's really such a broad topic. I would just say something Luigi said on the last question made me think, and I just wanted to drop it in, which is, when you're engineering this stuff, there's always decisions that you have to make that are either concessions in a certain place, or to excel in one, you kind of diminish your feature in another place. In my experience, that's what it's like anyway with layer ones. You can't have everything all the time at max. And so I would say, as Luigi said, it's important when you're engineering. It's important when you're engineering that, sorry, I have a visitor. Go downstairs, okay? It's important when you're engineering that you do so in a, okay. This is like the BBC News thing. Yeah, cool. Go back down to your mummy. Thank you. It's important when you're engineering that you do so in a way that you stay true to your value proposition. And I think Luigi was kind of saying that. You can put everything to 11, but if you do so, maybe you're not so decentralized anymore, or maybe you're not as robust as you want to be, or maybe you're not as secure as you want to be, or whatever. Okay, love you. Okay, love you too. Okay, cool. Okay, that's brilliant. Could have been worse. So these are the kind of things that you have to kind of take into account. And just on the composability, I won't take too much more time. Algorand's got some interesting ways to do things. We took the same kind of view that Ethereum and Solana did. We don't have kind of this composable blockchains as a layer 0 type thing, similar with Cardano. But we have this same account-based model, and we try to have composable elements. So as an example, we have primitives that you can declare. So rather than issue an ERC20 token where you have like JSON inside a smart contract, we have native assets as a kind of a class that you can declare on the network. And so you don't have to write any code to issue a native token. And with this comes a lot of kind of modular features, things like native ability or intrinsic ability to do clawback or freeze or administration of the token. Of course, these are optional and not necessarily required. And then finally, things like atomic grouping. So, this idea that you can put a bunch of transactions into an array and say, hey, they all must be processed at the same time or none of them get processed. I think these things are quite important composability kind of considerations. But again, it was done with the hindsight of looking at what Ethereum had achieved and then being able to build on that. Yeah, that's what I would say.
Well, I want to say well handled, John. First of all, been there. I have 2 little kids too, so I get it. Yeah, so I think a lot of these points make, sort of along the same lines of kind of why we took the approach we took. I think in designing Avalanche and sort of like how the architecture was pretty purposeful from the start. Fundamentally, we believe there are different use cases for either digitizing assets or needing block space in general. And I think fundamentally, we believe that not all of those use cases can exist on one state layer. That's at least, sort of a very principled thought that we kind of have. And because of that, you might have a situation where you have some, I don't know, Telegram messaging application where every single application is a transaction, every single message is a transaction. This is probably going to require different type of decentralization. This is going to require a different type of security than something like settling US stocks, on a decentralized ledger. And so because of that, we partition that via different subnets because we don't expect that settling a stock transaction could be or could expect to be hampered by a lot of people sending memes across the Telegram message channel, right? So partitioning the load is just generally speaking a fundamental value that I think we consider. And in terms of the composability, somebody like myself who's very focused on DeFi, this is incredibly important. I think flash loans, as Austin mentioned, is the #1 use case or the #1 issue as it relates to cross-chain composability. Most of the other ones are generally solvable, but that one is sort of harder. And that's why we believe that, what we've recently introduced with Avalanche Warp Messaging, AWM, this is the way that all subnets can talk to each other via arbitrary messages passing, sort of like how the message passing bridges were mentioned before, without introducing new trust assumptions from the validator set. So you kind of already have the validator sets that are sharing amongst the network. And because of that, we use the form of BLS signatures for them to send messages. And I think that architecture allows for growth of different use cases, which we don't know yet because it's very early in the space how people want to use this technology. For example, yesterday or 2 days ago, there was a subnet that was launched, which is asset-backed security tokenization called Intane on Avalanche. This is a more private type of subnet that the validator set has to be in a certain jurisdiction. They need to adhere to certain regulatory requirements. And that sort of customizability, we believe, is going to be very important for different use cases going forward.
Yeah, so maybe adding my perspective as the EUTXO blockchain, which usually is asked for, hey, do you have a bridge that we can also build on EVM and then interconnect with Cardano? So for us on a very high level, it's important to have those patterns in place and like a toolbox from which we can just pick. And so it was a pretty good idea from IOG to come up with that L2 sidechain toolkit that they proposed, which is actually not a pure tooling, but also a specification, like an open standard of how to build a sidechain and plug it to the Cardano blockchain, which makes our lives much more easier, because otherwise we would always start from scratch, so to say, and solve the same problems all over and over again. That's why it's so important. On the other hand, being a bit of a zero knowledge proof fanboy, I'd say there's a nice thing I recently read about. It's from Succinct Labs. That's called the proof of consensus approach. And this really sounds interesting, because you implement a smart contract basically on your chain, which proves the consensus of another chain. And so it gives you a very nice asset and neat way to express the consensus and therefore the state on the other chain without needing to roll up, for example, the whole chain from one to the other.
It's super interesting. Yeah, when it comes to Polkadot approach to composability, I mean, we consider Polkadot to be L0 or relay chain, and then the biggest advantage of that is actually the shared security concept, which all the parachains attached to Polkadot get to leverage when building their specific chains, and then apps on those chains, and then layer 1s, layer 2s, layer 3s, all that stuff. So from that perspective, I think what was crucial in the beginning was obviously having a good SDK to build those parachains, and leveraging the shared security, which is always the biggest hurdle when you're starting a chain. But I think you pointed out this correctly. The biggest kind of challenge there is to actually, when those chains are live, now to actually have them communicate and leverage each other, basically. So, and that's what we're doing with XCM, which is our cross-consensus messaging format. XCM is, I think we merged it last week, the V3, which adds basically a multi-hop, which will allow bridging over XCM messages. And currently we have two trustless light client bridges being built out, one to Kusama and one to Ethereum in our ecosystem. And yeah, so when I'm saying this, like we talked about composability, and I think it's also interesting to mention that parachains in the Polkadot ecosystem, or all these chains connected to us, obviously most of them are basically projects from the ecosystem that have their own tokens and have their own business models. But Polkadot also tries to move all the functionality away from the relay chain into these parachains as well. So we used to call them common good parachains. Now we call them system parachains because it's a little bit of a better name. And we have a few of them, mainly Statement and StateMine, which handle all the assets of the Polkadot. We have in the future, we plan to move staking and governance as well to its own parachain. So that's kind of our approach to this composability, is like having a bunch of chains and then having XCM, which leverages communication between them. Obviously, that's not necessarily the best solution when it comes to composing these like transactions that need to happen in the same block, like what Austin was talking about. But I think for that, the best use case for that would be to just because we were using Substrate to build to help people build their chains. Substrate has Frame, which is a framework of Rust palettes, and I believe that potentially the future is actually composing these palettes inside of a chain, and they're all going to be in this one big palette marketplace. So that could be something that in the future could be a solution for this type of problems.
You know,
Yeah,
can I just add one extra thing just on something that Stefan said that I think is interesting? You know, we've all got these cool technologies with smart people working on them, like the bridging technology, Mithril type stuff on Cardano. We have the state proofs, which use post-quantum signatures, and it's all very elegant and cool. But the problem is we've got too many of them. And so I'd nearly be willing to give up on owning the technology so we can all agree on a technology to interact with. And I know there's IBC, and I've looked at that as an example, and I'm not pooping on IBC, but it's quite complicated to implement outside of the context of Cosmos. And so a big part of me, just like the internet, we have TCP/IP, we all use it. We have HTTPS or whatever, we all use it, right? A big part of me would just love for us to kind of get into a room and then just agree, okay, it'll be this one. And I honestly think it'll behoove the entire industry, and hopefully then we can crush Ethereum together, you know?
Look, there's an XKCD for this moment. Right.
For sure, and for sure, yeah, for sure, there's XCs. John, I think that's actually what Gavin meant with XCM. I think he tried to make it as chain agnostic as he could, and currently with this bridge between Ethereum and Polkadot that is in development at the moment, we're kind of experimenting with teaching Ethereum XCM. So I think it would be very interesting. We plan to launch these bridges end of Q1, beginning of Q2. So I think it's going to be very interesting for people to look at this as an example and potentially agree on a common format. I mean, I'm not saying that this might be it, but I think it would be definitely interesting to take a look at it.
Yeah, I do want to say, just before we kind of move on, that one of the things I think we have a challenge with in the industry is common definitions. And one of the pieces here is I think we need a new term for a lot of the composability that some of you are describing here, because it's not what composability meant on Ethereum. It's fundamentally different, right? And different is okay, but taking the same word that means you can do one thing in one space. And, you know, there are solutions with bridges and subnets and messaging and all sorts of things to create new systems that, you know, can bring opportunities similar to what composability can bring. But I do think it is important that we figure out kind of where we're changing some of the underlying technology in ways that maybe require a different name to the thing, which is not to say that something is better or worse, but just, you know, trustless bridge is another one of those terms where, like, I'm a huge fan of state proofs. Like, state proofs are coming to Solana as well. I know a lot of people are doing cool things with them, but like the term trustless bridge is thrown around very cavalierly when it's not actually trustless, it's trust minimized. And I feel like the same thing is starting to happen with composability as more networks have distributed scaling models. We should figure out just a different term for what that looks like, I think.
Yeah, thanks.
Okay.
Thanks for all the... Sorry, go ahead.
Sorry, I just when I said trustless bridges, what I meant is like client bridges. That's what I wanted to say, and I agree that I should have been more careful, I guess.
Yeah, I mean, thanks for all of the nuanced detail there. But before we move on to kind of like the ecosystems and the users, I do, because there was a decent amount of talk about this in the chat and in the Q&A, the whole idea of decentralization, right? So a lot of you brought this up. You know, it's a word that gets thrown around a lot in the space, but it is at the center of why we are all here, right? So in the report, you know, that we wrote, we tried to quantify it using a couple of different metrics, but I want to do the same thing again here. I just want to go around and get your ideas on, you know, how do we define decentralization, right? Is there a way that we can measure it? Is there a way that we can use these metrics to, you know, go across L1 ecosystems and kind of see what degree of decentralization is there, right? So can you talk a little bit about that? Let's start again with Austin.
I think this is a little bit like trying to define what democracy is. We can all agree that certain countries are more democratic than others, but the ordinal ranking there is a very hard thing to actually figure out. I think there's a lot of important metrics to look at, and one of the ones is obviously the number of nodes, the super minority of nodes on a network, the absolute count of copies of a ledger, and the other one that, you know, quite frankly, Ethereum and Bitcoin are ahead of any of us on is multiple clients. Having multiple versions of clients written in independent languages with independent dependency trees is really important for certain types of bugs that could hypothetically corrupt the entire ledger of a system. So there are those sort of doomsday scenarios where, you know, you don't have an early warning system to pick up the pigeons. It's for the time that the missiles might hit, and they never will hit, but you still have to have the radar, right? That's kind of when you're looking at multiple clients and systems for something like that. I will also say that, you know, there's a lot of arguing on Twitter about whose blockchain is more decentralized. I don't think there's any blockchain that exists today that's sufficiently decentralized for any of our ambitions. No one has enough validator clients. There's only 7,500 nodes that actually run ETH2, and there's 5 entities that could compromise all of that. That's pretty good, but that is not sufficient for the visions any of us have for where this technology could go into the future. But I think decentralization is kind of, you know, it's a point system, right? You can figure out what matters to you and what matters to your project for what you're building. You can assign points to various networks and you can aggregate score at the end. I don't think it's something as simple as looking at what's the Nakamoto coefficient, what's the total number of validators, what's the number of clients, or anything along those lines. I will say, though, that one piece here is permissionless validator systems, I think are something that everyone should strive towards and really be able to hit. I know that on some networks, like Cosmos has some technological limitations that keep that number in the sort of low hundreds for now. They're working on a bunch of work like that. But there's other networks that have a hard cap of maybe 100 or something along those lines. I think like what Polkadot's done with the nominated proof of stake systems is kind of an interesting solution that's kind of, you know, in the process of getting to anyone can run one, but there's a limited committee selection in that model. A lot of this stuff is very hairy and very technical. But I think the biggest message is that there's no chain that is sufficiently decentralized with a sufficient number of nodes, I think, to meet, let's call it, you know, several $1 trillion of USDC on chain.
I think that's fair. I would just kind of add briefly, you know, for me, the way I look at it is how many entities need to collude. And so I think the point about the client is a very interesting one, actually, Austin. I hadn't really thought about that recently, but, you know, I remember working on Ethereum and having all these clients to choose from. And on Algorand, we just have the one referential client, our canonical client at the moment. And so for me, it's like how many entities need to collude. And so I agree, look, you can look at it in so many different lenses. You can have a really decentralized consensus mechanism, but then you can have your kind of decentralization magnitude or score diminished by some other aspect of your network's architecture. And so when I look at even Bitcoin as an example, okay, it hashes away with SHA-256. It's been commoditized into application-specific integrated circuits, so you can buy these machines that just do it. And you might say, in a way, it's extremely decentralized if you look at the raw terahashes per second or whatever. But then you look at how many mining pools have to kind of just like shake hands to start messing around, and it's actually quite a low number. And so there's just like Austin said, so many different ways to cut it. I would agree, it's a spectrum, it's a place to get. It's not a binary. It's not like you are, you aren't. And I think we're all doing a reasonably good job at becoming decentralized. And certainly at Algorand, and I know I agree. I would suggest that everyone on this call, it's a primary star in our roadmap. It's something we care deeply about. And so we're going to continue to try to decentralize further.
Yeah, I would agree with a lot of what was said. Generally speaking, in this space, we don't have very good definitions. A lot of that is because things are moving at very rapid pace, and there really hasn't been that, I guess, academic studies and ability to define things that, you know, everybody has sort of, you know, congregated amongst. With respect to decentralization, let's not like forget the whole point it was included in the first blockchain, and it's really just censorship resistance. That was the whole point of it, right? That's why, you know, you need a distributed ledger. You need to be decentralized. This way, if somebody tries to attack one, there are multiple copies, and that really can't be done. So we don't know. We don't have a number. We don't have a metric to say today and be very confident and say, hey, this is sufficiently decentralized. I think there are ways to measure and to think about it in terms of like it's sufficiently decentralized under these scenarios. But there are multiple different things to think about. Geography is one, jurisdictions is another, clients is another, centralization of actual stake or coins is another. So it's not just decentralization as it relates to how many nodes, because as we see with like Lido, for example, or Coinbase or whatever on E2, like, you know, you can have one entity that just has so many nodes, right? And so that's not a good measure. Although obviously something like Nakamoto coefficient is a useful data point. It's not tantamount for anything that you would base everything upon. And so, you know, I think we still don't have a good answer to this, I would say. But at the end of the day, if the blockchain has not been attacked, if it is censorship resistant, for the moment, that would define that it's sufficiently decentralized. And that's all we kind of have right now. And hopefully the space will push forth and kind of, you know, do a lot better as it relates to measuring this.
Yeah, so actually not too much to add, I would say, to the words before. For me, it feels like it's a process. So even with democracy, I think there is not a single country on the planet that can claim that it has the perfect democracy. And it would be actually the question, what is perfect democracy? Or is the perfect democracy actually anarchy when everything is completely decentralized and no one is following any rules? So maybe we need to figure out what kind of chaos we need to allow in order to have that decentralization in place that we really need for the purposes that we build our systems for, and then probably work together on figuring out what would be a good objective measure to measure the decentralization of a blockchain. Like, for example, we kicked off the research activities with the University of Edinburgh and the Edinburgh Decentralization Index, which takes those things into account, like where are the nodes, in which countries, under which regulations, and so on and so forth, besides all the technical stuff. Yeah, so I would really say it's a process. And that's actually also an argument against all the standardization. Because, I mean, being German, I love standards, that's for sure. But sometimes it also helps if you allow that freedom to be probably not standard and somewhat custom, because it also can be an error mitigation strategy. Brave statement from an engineer, sorry.
I'm not going to repeat anything that was said, although there's quite a bit of overlap in what how we're thinking at Parity and what we're doing. But I just want to give a shout out to the report by the blog, which mentions something that I think not a lot of people are talking about, which is centralization of the access points into the blockchain, right? And this is another part of decentralization and another part of censorship resistance and manipulation that is not nearly as talked about as I think it should. And this is something like, for example, Polkadot has like one of the second highest or one of the highest Nakamoto coefficients, but this is not something that we consider super relevant. We've been what I'm specifically very proud about is we've been working in Parity for the last 2 years on a web-enabled light client, which completely cuts the need of going through our RPC endpoint. And basically, in an extension or even a part of your web app, you can spin up a client and basically just communicate through that client with the network, submit transactions, or query the network itself, and then spin it out basically in a tab. You just open up a tab, it spins out, you close the tab, it goes down. And these types of tooling, and there's many more that I can count that we don't have and we want to have, but these types of tooling are what is slowly getting us to that ever-moving goalpost of true decentralization, which I guess maybe we never achieve fully, but it's a North Star for sure.
Yeah, we can talk about each of these subjects for an hour each. Unfortunately, we only have an hour, and looks like we got about 6 minutes left. So, so we will have to move on to our next big topic, which is the developers, who are developing decentralized applications, and the end users who are using these said apps. So just quickly from each of you, at the end of the day, right, we all we need is disruptive applications that has mass market appeal. That's all we need, right? So we kind of saw that, though. We kind of saw a little bit of that through stable coins, the dissemination of stable coins, DeFi summer in 2021. We saw NFT or DeFi summer in 2020, NFTs in 2021. But as far as the users go, the developers and the end users, what kind of overall trends are you seeing, and what types of metrics are important to you? And let's start with Austin.
Yeah, the Electric Capital report is kind of the gold standard for developer reports in the ecosystem, largely because every L1 I know complains about it, undercounts them. And if everyone's complaining about a report, it probably means it counts everyone at least comparably. Sort of like, NPS is kind of a meaningless metric, but if everyone uses it, you can kind of do some rough comparisons. So, what did the most recent one show? Solana grew 83% from December 2022 to 2023 in terms of number of active developers building in open source repos on the network. That's the fastest number. That's the highest growth number that we see, and it's sort of second behind Ethereum in terms of total number of devs in these places. One of the key metrics that they track here is full-time developers. I think that's really an important one to look at, especially over a longer time horizon. I think Electric Capital defines it as 10 or more commits to a repo a month, which is a pretty serious number of commits to a month for certain kinds of development models. But that full-time piece shows that people are both fully committed and they're able to actually start projects that are paying them enough money that they're able to actually go full-time into Web3. And for me, that's one of the most important metrics to look at are the people who are going through, I think, most everyone here has really good educational initiatives to, help developers transition from Web 2 to Web 3, or just straight out of college or straight out of a technical school, dive right in and start building natively on Web 3 and sort of skip the Web 2 4 years of career. But one of the most important metrics there is, are they able to make money? Are they able to actually build projects that are successful enough that they can continue developing? We're not trying to make people, filthy rich here or something like that, but just enough that this is a viable full career path. And that full-time developer metric is one of the ones that, I would say we particularly care about at the Solana Foundation when we're looking at how this thing's going and how developer adoption's going. It's been a rough year for that across the board. I think if we look at just sort of people's abilities, there have been massive layoffs in the Web 2 and Web 0 tech industry, and I think we've seen largely that crypto has been immune from most of that. We have not seen massive layoffs by, most of the leading blockchain foundations or development partners or projects shutting down or, in a desperate situation. And that really, one of the things people underestimate about building in this space is how few developers it takes to make a project that hundreds of millions of people may or do use. That's a very different ratio than you see in Web 2. So that's just some of the ways that we tend to think about this stuff at the Solana Foundation. But I think 2023 actually is going to be a pretty great year for the industry in general. I think we're past a lot of I would hope at this point that any centralized entity that was severely over leveraged or stealing customer funds has been flushed out of the system. And we're in a place where, we're fingers crossed, right? That we're really in a place now where we're ready to start kind of refocusing and rebuilding a lot of these core components that I think a few of us have talked about in this panel drifted into the centralized aspect of stuff, whether that's, huge pieces of infrastructure built on the very small numbers of multi-sigs, or whether that's users choosing to use centralized systems, or whether that's the collapse of something like Terra that a lot of people saw coming and called out and a lot of the industry just ignored. Hopefully we're kind of in a cycle where we're back to building products that are going to be compelling to consumers and are going to bring lots of new people to the network for something other than just either building or investing on the network.
I'll go next. I'll keep it short because I know we're short in time. The developer experience is so core to what I'm doing. So what I've done the biggest thing I've done for the last 8 months at the foundation is work on the developer tools. Algorand had developer tools that were not great. And so we've rolled out a new tool called AlgoKit. It's kind of soup to nuts, everything you need to build. And I'm modeling it on what it's like to build an iPhone app or an Android app where you've got a line-by-line debugger, you got a simulator, you got a tool like Hardhat, Truffle, that kind of thing that can bring you through build, test, and deploy. And so for me, just the most important thing we can do is improve the developer experience across the board in Web3 to make it fun and easier to build this stuff. And of course, then for enterprise grade clients who are building serious things, to make it so that they have the tools to avoid the mistakes that they commonly make. So yeah, user experience is primary.
Yeah, I would just say, not too much to add here. Avalanche started obviously focused on the EVM, just as a demonstration of sort of how you can take a virtual machine and put it on Avalanche consensus engine. And so we did invite a lot of the EVM developers to come to Avalanche and have seen some real success with that. But now with, I think over the last maybe 6 months or so, as we sort of improved our subnet SDKs, we've seen a lot of interest with respect to developers that are interested in WASM. We recently deployed a Rust-based SDK, so developers can deploy Rust-based subnets. We also developed. We also have a Move subnet that people are developing at the moment. So the developers really, as we think about it, sort of span the gamut. We're trying to provide, at the end of the day, the most customizable, flexible piece of architecture, such that if you're a developer, you can build what you want. That's literally the mission for us, where it's just a much less opinionated protocol, by design.
Yeah, my answer to this is just two things. I'd say it's education for the developers and people that want to build on our technology, and not only with regards to the technology, but also on how to build a robust business model, which is especially in those times like last year and maybe also again this year, especially important. And then it's accessibility. That's, for example, one of the reasons why we came up most recently with a new smart contract development framework called Aiken, because probably not everyone wants to write Haskell code for its smart contract, and feels more confident with something else. So it's education and accessibility in the shortage of time, I'd say.
Yeah, I'll go super quick. Yeah, we're also working hard on the Ink, which is our smart contract language, Cappy, which is our new and improved JavaScript API to connect to the chain. But what I would like to give the biggest shout out here is to Polkadot Academy, which has successfully finished this week its second run. It's been 4 weeks in Buenos Aires and the university there, and with lectures from basically the people who made the code, and Gavin talking about cryptography, and some of the researchers from the Web3 Foundation, and some of the leads and developers from Parity and other companies.
So we may have some technical trouble there. Yeah.
Do we?
Yeah.
I could hear you.
Stefan, I think you dropped off there. Oh, okay.
Oh,
I think it's my internet. Whoops.
Yeah.
Right.
Yeah, just to quickly to sum it up. So the next Polkadot Academy is going to be probably in the summer, and I hereby encourage everybody to apply. It's very interesting. You learn about blockchains, cryptography, a little bit about Substrate, and in general, I think it's really fun. It's super cool, and scholarships are given for the time you spent there. Also, our treasury is pretty decent in size, still in the bear market. So I definitely encourage developers to apply for treasury grants and fund their projects. And yeah, let's have a amazing 2023 with building and focus on building, basically.
Well, sorry to cut you off there, Stefan, but I really enjoyed the conversation with all of you. Unfortunately, we are out of time. We're slightly over, so I hope you don't mind. But again, thank you for taking the time to all our panelists for joining the discussion. And thank you for the audience for tuning in and asking such great questions. I wish I could have gotten to a few more of them. But I hope to see you all at the Block's next webinar, and have a fantastic rest of your week.
Thanks.
Cheers, guys. Bye-bye.
Cheers.
Bye.
Thanks, guys.
Bye.
Bye.
Bye-bye.